to discuss for today. One is A/B testing. So, anyone have any idea about A/B testing? Um, A/B testing is simple, nothing but considering the two cases. Like for example, if you develop an app and you want to check the interface of the app, and you develop like two versions. So based upon the user like interaction and the user interest, you will decide, okay, this interface is perfect for the users and I will go with that. So when the companies develop anything, they want to decide like which one is good, and they will prefer this A/B testing to decide which version is good. So A/B testing, it is used by many large social media companies, Meta, for example. Like what is A/B testing? So we are using some statistical methods to decide which version is good. Because if we want to decide something is good, like we need something to measure, right? So we use statistics for that to decide which version is good for the best user interface. A/B testing, also known as bucket testing or split run testing or split testing. It is basically a research method that is used by many companies to decide which version of the product is good. So they will develop multiple versions and they will perform A/B testing and they will decide, okay, this version is perfect for the users and we are proceeding with that. There is like one thing about A/B testing. In A/B testing, you basically will do more than what is required, because you will develop multiple versions and you will check, okay, this version is perfect for the users. So you are doing the more work than what is required. So that is explained by here, like turnout A/B testing is hard. And let us consider a simple example. Okay, so select a single item to change. Um, for example, there are two cases. One is like if the offer is going on, like the offer is ending soon, that is one of the case. And the second case is offer ends at midnight, like midnight tonight. For example, there are two people and they are saying that if we prefer to keep offer in soon, we will get more sales. But the other person said that, like if we prefer the option of keeping the offer ends at midnight, we will get more sales. So there are two cases here. So based upon A/B testing, we will decide which one is perfect or which one is best for the better sales. So we will compare this with the statistics. So we consider H naught as this is fine, and for HA this is better. So how you will decide the metric? Like for example, once you build a model, like in your projects, like how you gonna decide like this model is perfect or not? So based upon some metrics, right, you will calculate the accuracy, precision, recall. There will be some metrics. So in this case, like what are the metrics? Like it is based upon the clicks of the user, and one is the purchases and the time spent on the sites. So these are the metrics. So we choose a sample size for some time period long enough to reach the chosen sample size. Let us randomly offer, like for example, we can consider A to the half of visitors and B to half of the visitors. And alpha versus beta. So previous we discussed about alpha but not beta. So now let us discuss about that. So alpha is nothing but type 1 error, which is false positive, which we already discussed. And coming to alpha, like incorrectly rejecting the null hypothesis, and alpha is the significance level and confidence level is 1 minus alpha. And what is the beta? So it is the probability of making a type 2 error. So alpha in simple, it is the probability of making the type 1 error, and beta in simple, it is the probability of making type 2 error. And incorrectly failing to reject the null. So in type 2 error, we are failing, like we fail to reject the null hypothesis. And the probability of wrongly getting a non-significant result, and 1 minus beta will be the power of the experiment. Because we discussed about alpha, which is a significance level, and 1 minus alpha as confidence level. Then coming to the beta, like what is beta and what is 1 minus beta? So it is the probability of getting a non-significant result, and 1 minus beta will be the power of the experiment. So typically higher values are accepted for beta. And so this is, you can consider it as a confusion matrix. Like for example, here we consider the population and the sample. And like for the sample, if you get like reject H naught, which is H naught as false, it is correct, because what we are saying for the population, like what we are saying for the sample, it is the same for the population. So it is correct. But if we fail to reject the H naught and the case is H naught is false, so we get a type 2 error, which is beta. And we reject the H naught, but the H naught is true, type 1 error, and we fail to reject the H naught, but the H naught is true, so it is correct. So this is what we discussed as before. So we are making some observations for the sample and checking with the population. So if we do some observations for the sample and we got the same for the population, then it is perfect, there is no error. But if we get something different, then type 1 and type 2 error will come. And calculating MDES. So why do we need both alpha and beta? So we can calculate the minimum detectable event size. So this is the number of samples we need to collect to be 1 minus beta confident, like we are not missing incorrectly failing. Like for example, we already have alpha, but why we need a beta? The thing is, we are using the two-tail test by using the alphas, but we still calculate beta as one-tail statistics. And these are the values for like alpha and beta. Like for alpha equal to 0.05, we know the z values, which is 1.96, and for alpha equal to 0.01, which is 2.326. And what about beta? If beta equal to 0.2, we'll get 0.084, that is z beta. And this is the graph explaining alpha and beta. So if you observe the violet, so this is, so so this is 1 minus alpha, like that is, I mean, that is 1 minus alpha by 2, and this is alpha by 2, and here we have the beta values, and this is 1 minus beta. So this is the graph simply explaining the alpha and beta values. So calculating MDES, Z, if you observe that Z alpha by 2, which is a critical value for your two-tail test of the acceptance region, then what about the Z beta? So it is the critical value for one-tail test of correctly rejecting H naught. And the sigma square will be the variance of the distribution. And we can consider these are the formulas for the Z and for the N. The key points on the previous slide. Okay. So in simple, like in A/B testing, we basically consider the different versions, right? And we consider like half of the people for the one case and half of the people for the another case. So in previous, we discussed about two cases. One is saying that we prefer to say that the offer is ending soon, but the other person is saying that it is good to keep offer ends at midnight. And we are randomly assigning those to the people. And next, based upon these results, we will decide like, okay, which version is perfect. And there will be some A/B testing is important to know. There are some interview questions, like if you attend any data analytics or data science interviews, you will get some questions related to A/B testing. So there are some validity threats. One is stable unit treatment value assumption, an assumption that one group does not interfere with another group in an experiment. Yeah. So previous we consider two cases that, and you consider that, like for example, you consider like one group is not disturbing the another. So it comes under the stable unit. And what is survivor bias? You are drawing conclusions for an incomplete set of data that only a fraction of the data survived. For example, like from the past few months onwards, there are several flight crashes, right? And like some students, like, you know, like some people, they decide like everyone is died in the flight. but the actual thing we really don't know whether some are survived or not. So without knowing the complete set of data, you are making some assumptions. So which comes under the survivor bias. And sample ratio mismatch, that is the ratio that you consider when you are doing the A/B testing. And what is the primary effect? Like for example, few days back we got iOS 18, I think. So some and what is the major changes in that iOS 18? One of the change that I observed is we have a image background. Like if you give your image, you will get the AI photos, right? That is one of the change in iOS 18. So some will like that change, but some people they say that it's not giving the exact image of the original image. So the primary effect is a temporary decline in the KPI given that users are resist to the new change. So like there are some users, they won't like the changes that are done in the new update. That comes under the primary effect. So what is the novelty effect? Sometimes when we got the updates, like we are much excited to use that updates, but as the time passes, like we will lose interest in those updates. So that comes under the novelty effect. So other effects to consider: day of the week, instrumentation effect, and the competition. So those are some of the validity threats. Yeah. And next, let's discuss this now. This is you are going to use everywhere in your projects. So what is this? This is basically you can consider it as a confusion matrix. These are the measurements that you use after building your model. So you build the model and you are now in a stage that you need to decide whether your model is predicting the things correctly or not. So this is what we already discussed. Like if the predicted value is positive and the actual value is also positive, that is true positive. For example, you got a data set and your model need to predict whether this person is male or female. So you gave the data set to your model and you calculated the confusion matrix. For example, if your model is correctly predicting male as male and female as female, so then there is no error. But if your model is predicting, if you give the male person and you know that this is the male person, but your model is predicting it as a female, so then it is an error. And those values can be observed by using confusion matrix. So true positive, false negative, and true negative. And these are the metrics that you use while building your model. You will calculate the accuracy by using those, like true positive plus true negative by all the values you consider. And for the precision, recall, F score. So these are all the metrics that you consider in your model building. And there are, I think there are other values, the precision, negative predictive values, recall or sensitivity. So based upon these values, you will decide, okay, my model is perfect. If not, like what are the changes I need to do? So that's all for today's lecture. I think we are done. Yeah, project. Sorry. So we successfully formed the teams, and tomorrow you will get the data sets. I think everyone finalized the projects like topic, right? Like for the project. And tomorrow we will share the document for the project. Okay, that's all. Tonight, sorry, I forgot that day. Okay, that's all for today. It's simple. Know about the hypothesis testing. If you get a homework, it will be easy for you to understand. Even though I explain a lot, when you do the homework exercises, it will be easy for you. Okay. And now it's the time for the attendance. 1 second.